Okay, so we're going to talk about factoring quadratic trinomials when a equals 1, and then we're going to look at it when a is not 1. So let me just cover this up just so it's not distracting. All right, so let's talk about what we're going to do first. So we're going to kind of look at this structure here, and this is standard form, so you need to know what the standard form is of a trinomial, quadratic trinomial. So this is standard form of a quadratic trinomial. Now, that's important kind of for just recognizing some pieces. So there's a strategy called the X games strategy, or we can call it X games. It doesn't have to be called an X games. It's just, we're going to look at some stuff. So if you use this strategy, it works every single time as long as you can multiply and add. So what we will do is we are going to look for factors of some value a times some value c, and we'll put the factors here. But it's really important that those factors do something, and those factors have to sum to the b term. Okay, so a, c, b, what does that mean? Well, we go back to standard form and we can see those three letters, and so those three things are going to get part of the game. So we're going to use the actual coefficients of the quadratic function that we're talking about to help us kind of figure out how to factor it. Now that's assuming it is factorable, and sometimes they're not, but we're dealing with things that are factorable. So they won't always be, most of the time they won't be, but in this situation they are, and it's helpful to understand how to do it. So if I take my X games and I just put it off to the side here and I kind of look, a times c, well, I need to figure out what is a, b, and c in this problem. So a equals, b equals, and c equals. Well, a is the coefficient of the x squared term, so it's 1. B is the coefficient of the x term, which is 11, and c is the constant. It doesn't have a value, so it's 18. Make it look a little bit better. And so now I know those three values. So the top is telling me a times c, 1 times 18, so I'm looking for factors of 18 that add up to 11. All right, well, this is where you have to do a little problem solving sometimes. Now, sometimes these numbers come right to you, and sometimes you just got to think a little bit. So it's important to see the best strategy for that. So when I do that, I list my factors, and I start listing all the factors that might work, even if some don't work. And some of you will get this so fast that you won't even need to do this, but if you are trying to understand it, sometimes there'll be negatives and sometimes there'll be opposite signs. But when I look at these factors, 1 plus 18 doesn't equal 11, 2 plus 9 does. So these are my factors that would sum to 11, right? So this does equal 11 if I add them. So I'm just going to put those two factors in my, like we talked about over here. And now what that means is they are factors of the middle term. So I can rewrite this as a binomial, just plugging in those values, and this is factored form of our trinomial. So these are the factors. Well, we can kind of test it. We can go back to an area model, which is a technique you should have learned for multiplying these two. So I'm going to multiply these two. Then I'm going to multiply these two just to prove it, and then we're going to kind of work through these relatively quickly, because this strategy is really important that you know how to use it for when a is greater than 1 if you want to be accurate 100% of the time. So 3x plus 4, so I'm just going to put my binomial over this, and this is an area model, and so we're going to find the product. So if you've never seen this before, there's some seriously good logic to this in terms of making your life avoid the errors that you could make in a lot of the other methods. But 5 times 3 is 15, x times x is x squared, so the products of the two numbers go in the box. Same here, I would get 20x, here I would get minus 3x, and here I would get minus 4. So the product of these two binomials are these four numbers, or the sum of those four terms. And what I can see is that I have two terms that are the same within this sequence, which is these middle two terms, right? This positive 20 and this minus 3x, which is true in my area model, which is almost always the case. Now, it won't 100% be the case, but the majority of times these two things will be congruent. So, or not congruent, I'm sorry. combinable. They'll have the same variable. So I can add these two together, and 20 minus 3 is 17. So if I rewrite this just to simplify it all the way down, this is what I get right here. So let me get this a little bit better. So how can I kind of use that just to prove it? I'm just going to do that over here really fast. And I'm going to put the x plus 2 here and the x plus 9 here. And I can see if I multiply, I get x squared, I get 2x, I get 9x, and then I get 18. And if I look, I have a 2 and a 9, so I get x squared plus 2x plus 9x plus 18. And then these two would add up to 11x. And I would be back to where I started with my original trinomial. So this shows us that the factors that we would just plug right into the area model are the factors within this. And that's really because this a term is 1, which means we really don't have to go any further once we know our factors when a is 1. It simplifies things. So let's play the x games on this next one. Again, 1 times 99, right? That is the top. That add up to negative 20, which is b. So now I should have, well, my terms should be, in this situation, I want to have some negatives, right? Because my sum is negative. So if I think about that, I know I need factors of 99 that add up to negative 20. So I'm going to list my factors. 1 times 99, 2 doesn't go in, 3 times 33, 4 doesn't go in, 5 doesn't go in, 6 doesn't go in because it goes into 96, 7, 8, 9 times 11. The problem is none of these factors would add up to negative 20. However, I do a little thinking and I realize, well, both factors could be negative. So if they're both negative, they would have a product that's positive. And notice that these two do add up to negative 20. So I can put my negative 9, my negative 11 there. And because x is 1, they just go right into my factoring process, and I am finished with that one. Now let's try this last one before we look at a being greater. So again, x games, I have a times c, right? So that's negative 30. That adds up to negative 7. So this could be a little more tricky. So what are factors of negative 30 that add up to negative 7? So let's just list factors of 30, and then we can go from there. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So if I look at any of these, only this one actually has a difference of 7, but it's not negative. However, since the product is negative, I can add a negative sign to the 10, and then negative 10 and 3 is negative 7, so 3 and negative 10 are my factors. And so I can just place those factors into binomials. I have x plus 3 and x minus 10. And that is my simplified answer right here. So we'll just kind of make sure we kind of circle it. That would be the answer. So our answers, we'll just circle them. All right, now these two strategies are really important in terms of being able to handle when a is not 1. So we start with the x games. We'll do kind of the same approach. I'll make it a little bit bigger, but this time 6 times 4 is 24. That adds up to 11. All right. Well, we're going to kind of do the same thing. So let's list factors of 24. Here are 24. What are factors of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. Do any of these add up to 11? Yes, these do. And since the signs are positive, I don't need to worry about it. Okay, so we filled in our x games. Now, the second technique you need to use when a is greater than 1, after we find our factors from it that we would use from a and c, we can go to the area model. So this is our second strategy. So our first step would be x games. Okay. If you do that, then your second step will be area model. And let's look at how the area model will help us. So let's put an area model right here. And it's pretty instant, honestly, how fast this will save you in terms of time. So we know that if we kind of go back to the example here, if I look at the product of these, the first term I have, the x squared term, is the first in the box. So 6x squared will be our first in the box. It's our x squared term. And our last in the box, the negative 4, was this c term. So I'm going to put what we have in our equation here is this positive 4. So, and I don't want to put the positive sign in. I want to get out of the habit of doing that. Only negative signs will I add. So what went into the other two boxes? The two things that added up to the middle term. So we can put the 3 and the 8, but they come with the x because they are the factors of the b term, right? So now that I have that, I have to go and look, and I have to look. All right, so I know some numbers are going to multiply to 6 and 3. So what number goes into both 6 and 3? 3x. 3 times what is 6? And x times what is this? So now 3 times what is this? 1, and 2 times what is this? 4. All this is plus and plus. So my factors are what's across the top, 2x plus 1. What's across the bottom, 3x plus 4. So two strategies to make this work, and it works every single time. Now there are other techniques, but they're a little confusing in many ways. But this is like procedurally very straightforward, and it works every time. And as long as you remember a times c here, so 9 times 2 is 18, that adds up to negative 9. We can now just find factors of 18, right? So factors of 18. Again, 1 times 18, 2 times 9, 3 times 6. Now, I do need the factors to add up to negative, so that means the product is positive, so both factors must be negative. And I mean, I can add factors, the negative signs to the others, but I already know these equal negative 9. So now I have my factors. I can go to my x games, making this pretty big. And the first term always goes here, and the last term always goes in this box. So the factors will go in the other one of the middle term, right? This middle term should have the factors here. So, and I can put them in either box. I really can. So, but what I do have to pay attention to is that since this number is not greater than 9, this number out here cannot be 9. It has to be the greatest common factor of both these, which is 3x. And up here would be also 3x, right? Because 3 times 3 would be this, x times x would be this. Now 3 times what is 6? Well, it's negative 6, so it'd be negative 2. And 3 times what is negative 3? Negative 1, so 3x times this is this. 3x times negative 2 is this. And we have our binomials across the top, across the bottom, and so we can just list them as our binomials. Now, yes, there is another technique called grouping, but I find this technique to be a little bit faster and a little bit more methodical and avoids some of the complicated errors that students make in the other technique if they're willing to take the time to learn this.